Hello everyone. Today I would like to talk about my final project for embedded system. I have designed this smart traffic system. Why I designed it? Um, Take an example of the traditional traffic light system. So here I have cars. These are the toy cars. So the particular lane seems to be filled, but this is the other lane. So this lane doesn't have any sort of vehicles, but the light for this particular lane seems to be green. That doesn't make sense, and the light for this lane seems to be red. So I wanted to change that because it is frustrating looking at the traffic light and seeing like the other road doesn't have any vehicle in it, and we still have to wait for that. So I wanted to create something which is smart, and it has a manual system because I want the collaboration between the machine and the human. So it has a manual system. Like if, for take for example, this is an ambulance. So this needs to travel to a particular hospital for saving the life of a patient. So traveling of them through the traffic, making it easier for them. So the traffic police officer could turn the light green for that particular lane where they see a truck ambulance. So I have this manual system also set up so that it helps for transferring the necessary vehicles like ambulance, and sometimes the patrolling cars could be the other major factor where this manual system could play a pretty much big role. So let's look into the slides. So overview of the urban mobility challenges. In today's era, the urban congestion poses a significant challenge. As talked about earlier, it is frustrating to see that the other lane seems to be empty and still has the green light and ours has the red light. So it is frustrating and time consuming. It is wasting our resources like petrol, diesels, because most of the time people don't turn off their vehicles, so it is the waste of resources. It causes more pollution, so it is a healthier alternative when we are adapting a smart traffic system. Then the role of the IoT in traffic management. The role of IoT in traffic management is crucial for optimizing the urban mobility by utilizing interconnected devices, intercity planners, and monitoring traffic flow, detecting congestion, and adjusting signals in the real time. It changes the signals in the real time. Detecting an object through the IR sensor, it shifts the signal within 5 seconds. So this data-driven approach not only reduces delays but also enhances safety for all users, because it's sometimes like we get frustrated and we move past across the traffic signal even though the light seems to be red for us. So it saves the life of the human who are going to be impulsive in that way. We can foster smarter city infrastructure that adapt dynamically to ever-changing urban land. Then the objectives. So in order to develop this, I have used the IR sensors and I have this dual operation. One is the smart one, which detects like whether this lane has vehicle. Again, the toy cars demos. With this lane has vehicle or not, it detects it and generally shift. So this lane has vehicle currently, and this lane doesn't have any vehicle. So it will be green light for them for the smart. And if there is a vehicle in here, but there are more number of vehicles on this lane and less number of vehicles, but I don't want this guy to be frustrated, so it will shift the lane after 45 seconds. If there is a vehicle, if there isn't a vehicle, then there will be a green light for this particular in as long as this other lane doesn't have any vehicle. If it has, give uh, shift the signal after 45 seconds to this lane so the other party doesn't get frustrated. So I've thought about all those scenarios because we people tend to get frustrated pretty easily. And then I have this manual mode in the sense like I have talked about earlier that the ambulance needs to reach to the hospital pretty much earlier because the seconds could decide the fate of that human or the personality. Then the hardware. So I have used Raspberry Pi 4 Nano IRT, 6 IR sensors, 6 LEDs, and six uh, resistors of 410. So LEDs are red, yellow, and green, two of each. So that was the hardware. Then the system architecture. So the IR sensors gives the signal. So IR sensors are connected to the Nano IoT 33, gives that signals to Nano IoT 33, and then the Nano IoT 33 communicates to Raspberry Pi through the broker MQTT broker. I've actually used EMQX for that, and then I have designed this web application, so it helps to shift from the smart and the manual. And then all this data is actually stored in the Firebase. So one is I have created, one is Firestore, and the other is real time whether the particular lane is active currently or not. It tells you that. And then talking about the Firestore, it tells you all the data whenever a particular lane was active. So I can use this data, whatever was stored in Firestore, in order to create the system much more efficient so that I don't have to use the IR sensor because they are quite sensitive. I could just analyze those results, the data which I have actually stored. So when was this particular lane active and when was the other lane active, and that would help me in order to decide like when I need to set a particular lane active and when I need to set the other lane active. So, not needing of all these sensors would be making my work much more easier. Then the software setup. So I have used Python language to do the code in the Raspberry Pi. Then I have used the C++ in order to do the code in the Arduino. The libraries I have used in was Wi-Fi Nina, because to establish a Wi-Fi connection between the Nano and Raspberry Pi, and in order to connect them to the MQTT. And then I have this client because it is the client-based application, so pub sub client. Then the Arduino JSON file in order to create the React app. Then the Firebase in order to store the data in the Firebase. So talking about the communication protocol, it is MQTT. So Nano is the publisher and Raspberry Pi is the subscriber for this. So Nano sends the data into the MQTT, Raspberry Pi receives the data and decides whatever it needs to do. So then the working principles of the IR sensors. So IR sensors has um, uh, it has one emitting diode in order to emit the light, and then it has a receiver which receives the light. So one is the transmitter, other is a receiver. So when it receives, like there is a movement in front of it or whether there is a thermal change in front of it, it detects that. So the it tells you like showing the count between. So I have these six IR sensors, and three are used for one particular lane and three are used for the other lane. So all three, it calculates like sum of all three IR sensor. It means like there seems to be a traffic at very extent end of the road, and if all uh, three values are true, and same it does for the other lane, like whether first two IR sensors are glowing or whether the first IR sensor is glowing or whether all the sensors are glowing or whether no sensors are glowing. So that is used in the A count and B count. Then the logical flow. So let me zoom it. So it starts, it checks all the lane due to the IR sensor. So it detects whether it has actually detected something or not. So it checks that, and then it checks which lane it is high for. Then it will be like green for that lane, and if the other lane doesn't seems to be have any vehicle, it will still be green for that lane. But if it detects like the other lane has a vehicle, it will shift after 45 seconds of the activation of that particular lane. So I have this manual system which overrides and switching, and then you can switch back to the smart system. Like manual system is whenever it is required for shifting of the like there's a particular ambulance, or sometimes this happens for the VIP as well. So yeah, the key features. So the real-time adaptive control, like it automatically detects like whether there is an um, vehicle present or not. So that talking about the using the database for that, it won't be the real-time detection, but it will be less cheaper, as I don't have to use so many sensors in order to do that. So in this particular, it is real time because it is detecting the activation of IR sensor at that particular period of time. Then it has the remote control via the web app, so you can just remotely control it with the help of the React application that I created, and I have deployed it, so anybody could have that link and remotely connect it if I have set up my traffic system, uploading the code on the Nano, and my Raspberry Pi is working alongside, so anybody could make the changes in the traffic light due to that. So I have deployed that using the React app and the Netlify in order to deploy that. So the data logging, so it checks, like it stores all the data with the timestamp on the file store, like this at this particular period of time this lane was active, at this particular period of time this lane was active. Then the fault tolerance, I have like if the Wi-Fi doesn't seems to be there, I want it to be reconnecting to that Wi-Fi, but I have still managed to do the like it could still work smartly even though it is not connected to the Wi-Fi. So it still works like how it is supposed to be working. And the other thing that I've done is connected it to the battery in order to make like connecting it onto the laptop is like sometimes it happens like the laptop doesn't seems to be working, but I have provided an extra battery for it so that it still works. And the other thing is like the backup option, like if it doesn't work to with the Wi-Fi isn't seems to be working properly, the functionality of the traffic system still be working, and it will also try to actually reconnecting to the MQTT and the Wi-Fi so that it can transfer the signal, because then the manual part won't be working. So that's so the conclusion to enhance the urban mobility throughout the IoT traffic solution, I recommend a multi-facet approach, like prioritizing the regularity adaptation of the Firebase and the security of it. If I am not using the IR sensor in order to do that, it doesn't detect the real-time data, but I'm actually relying on the Firebase data, whichever I have stored. Um, and so it needs regular contribution to that, and there needs to be security management in order to see like whether anyone has actually deleted the data, because that could cause a problem, as I'm not using the IR sensors in order to do that, in order to make this much more enhanced and um, making it industrial product. So that is the conclusion. So let's move on to the circuit and how all this is working. So I'll be shifting my camera into the circuit. So I have three IR sensors on a particular lane and three IR sensors on the other. One traffic signals for one particular lane and another traffic signal for the other lane, created through three LEDs and with three resistors on each side. And I have this Nano IoT 33 over there and a Raspberry Pi over here. So let's see the create different scenarios and how does this actually function. So it has a yellow light in here. Let me place a vehicle in here. So it should turn green after a while. Let's see. It has turned green, so this vehicle can pass easily. Let's do the same for the other lane. So it has a red light in here, and as I'm placing a vehicle in here, I want this lane to be green. So let's see whether it turns green. It has turned green as it has observed there is a presence of vehicle in here. So let's see what does it do for two vehicles. So two vehicles in here, it will say let's move. Now let's look into the scenario where a particular lane has more vehicle and the other lane has less vehicle. So what does it do with that situation? So it has two vehicles in there. Let's just do like two vehicles in here. This lane has two vehicles, and the IR seems to be all the IR sensor seems to be active. So green light for this lane, and only one particular vehicle over there. Let's see whether it will shift the lane after 45 seconds or not. So it is shifting the lane even though it has more number of vehicles in this lane and less number of vehicles there, because I don't want the other person to be angry at me. So let's look into the code now. So let's look into the code. Before talking about the code, this is the application, React application that I've created. It has a smart mode and a manual mode, tell you whether you want to be active lane to be A or B. So clicking on A, clicking on B, all those reflection is actually being stored inside the Raspberry Pi. So let's look into the Arduino code and then moving on to the Raspberry code. So I'm using the Wi-Fi Nina library, subclient pub subclient library for the MQTT because it is a client based. Then I'm using Arduino JSON just because I'm created a React application. Then I have suggested the digital pin to the IR sensors and the LEDs. Then the maximum key light for 5 seconds and the yellow time to be 5 seconds. Last switch seems to be 0 for the starting because at starting I don't want it to switch any lanes. So active lane also seems to be false at period of time because I'm like creating a prototype. So in the beginning, the active lanes needs to be false. Then the smart mode is always true. In the starting, it will be true. Then depending on the React app I have created, like whether the traffic officer changes it to the manual or not, depending on that, the smart mode will be changing. Then I have stored my credential in here. Then the Wi-Fi client, then I have this last MQTT reconnect. It's talk because I have done the troubleshooting with the backup and the reconnections, and there is a battery in my system. Then I have the setup loop, which setup which talks about the pin mode. So all of these are giving all the LEDs are giving the outputs, and all the IR sensors are taking the in. So the pin mode is that for all of them, and the digital write at the beginning seems to be green B, so B lane seems to be active in the beginning, and the A lane seems to be non-active in the beginning. Then it checks the like whether then it checks the whether actually there seems to be a connection of Wi-Fi or not. Then after that, what I've done is check whether it is checking like backup loop is active or Wi-Fi is active. If Wi-Fi is active, so run the smart mode. Then it talks about the connection, so it checks the connections. After checking the connection, it runs like this particular lane is active and it has more number of vehicles, so this lane will be active, other lane will be active only if there is a vehicle in there. Otherwise, the lane which had vehicles in it will only be active. So let's look into the Raspberry Pi code. So Raspberry Pi code, I have stored it in here. So I have so this is the Raspberry Pi code. It has the JSON file in order for the React, and it has the Firebase file in order to connect to the Firebase, and the MQTT file in order to connect to the MQTT in date time, because I wanted to store the date in the Firebase whenever the particular lane was active, and it sends the signals to the MQTT to print. Like if I wanted to check something, I can check the signal on the client, the MQTT client. like PDX, which I basically use to check verify the connection whether the connection is correct. So this is for